Hi students, this is Veenu with chemistry. We are going to study about want-of factor and extent of dissociation in an electrolytic solution. We all know what is want-of factor. Want-of factor is denoted by I. It is the ratio of normal molar mass to observed molar mass, or we can also define it as a ratio of observed colligative property to normal colligative properties. We will see that how this I is related to degree of dissociation. Now let us define what is degree of dissociation. Degree of dissociation. We know that an ionic compound or polar compound, when dissolved in a polar solvent, it dissociates into ions. So how much fraction of that substance or compound is broken into ions, is dissociated into ions? That fraction is called as degree of dissociation. The degree of dissociation is denoted by alpha. It is defined as the fraction of the substance, total substance taken, which get dissociates into ion. So amount of substance which is dissociated into ions, that is known as degree of dissociation. We usually don't say amount, if we say fraction of substance which is dissociated into its ion. So we'll find that it is degree of dissociation. Alpha is equals to number of moles of substance dissociated upon total number of moles of substance taken. Total number of moles of substance taken. So number of moles of substance dissociated upon total number of moles of substance taken. That is, it is the ratio of number of moles got dissociated to the total number of moles of substance taken initially. Now let us see mathematically the relation between I and alpha, want-of factor and extent of dissociation. We'll see mathematically. For example, we had taken 1 mole of substance. Initially we had taken 1 mole of substance. So we had taken 1 mole of substance. Let 1 mole of substance is taken, or solute is taken. And we find after dissociation, and degree of alpha is the degree of dissociation. Alpha is degree of dissociation. Now we will find that number of ions formed after dissociation, number of moles of ions formed after dissociation. Will be equals to m alpha. Total substance taken is 1 mole. Alpha is the degree of dissociation. How many ions are formed? M alpha. Now we will see now number of moles of solute which is not got dissociated, means undissociated. So number of moles of solute remain undissociated. is equals to 1 minus alpha. 1 minus alpha. That means alpha is the degree of dissociation. So we'll find that m alpha is the number of moles of substance formed, means molecules formed, ions formed, and number of solute particles which remain undissociated, not got dissociated. That is 1 minus alpha. Now we will see total number of moles moles of particles after dissociation. Total number of moles of solute, moles of particles, solute particles is equals to 1 minus alpha, which remain undissociated, plus which is formed after dissociation. 1 was total amount of substance taken, total number of moles of substance. Alpha is degree of dissociation, 1 minus alpha remain undissociated, and m alpha are the number of moles of ions formed. So total after the dissociation 1 minus alpha plus m alpha. So we'll find I is what? I is the observed number of, I can also be defined as observed number of moles. I am writing for number of moles n. Observed number of moles of solute. It will be having same relation. What relation is having colligative property? Observed number of moles of solute upon normal number of moles of solute. So we have seen observed number of moles of solute 1 minus alpha plus m alpha, and we had seen normal number of moles was 1. So I will be equals to 1 minus alpha plus m alpha. Now we will see further, this I is multiplied with 1, I will be equals to I equals to 1 minus alpha plus m alpha. I will be brought on left hand side of equation. I minus 1 will be equals to alpha plus m alpha. Now from here we will see I minus 1, alpha is brought common, 1 it will be I minus 1, it will be minus alpha plus m alpha. This we will take as alpha, it will be minus 1 plus m, this will become I minus 1 this will become alpha m minus 1. So this is the I minus 1 equals to alpha m minus 1. Now from here we will find the value of alpha will be I minus 1 upon m minus 1. This is the extent of dissociation having relation with want of factor. So if we see in case of for AB type of electrolytes, AB type of solutes or electrolytes, they break into 2, m will be 2, so alpha will be I minus 1 and 2 minus 1, it will be 1, that is I minus 1 only. For AB2 type, of electrolytes, let us see. I hope you got I equals to 1 minus alpha plus m alpha. Now on solving, these steps usually skip directly I minus 1 alpha m minus 1. From here we will get alpha on cross multiplying here I minus 1 upon m minus 1. For AB type we will get 2 ions I minus 1, 2 minus 1, it will be I minus 1. For AB2 type, let us see. For AB2 type of solutes, we will see m equals to 3 and I will be I minus 1, 3 minus 1, I equals to, alpha. Alpha equals to I minus 1 upon 2. For AB3 type, we will see it will be m equals to 4. So alpha will be equals to I minus 1, 4 minus 1. This will become alpha I minus 1 upon 3. This way we can solve for the alpha if we know the number of ions formed after the dissociation. In our next class we will see how want of factor and extent of association are related.